Good morning, ladies and gentlemen. My name is Sipho Samkelo Ngoza, a student of UNISA. My student number is 37201107. I'm going to be presenting to you a report that was assigned by a lecturer from UNISA to student. The title of my report is as follows: Proposal of upgrade of an existing road to a 4-lane road. Before I continue, I couldn't make this presentation on Teams. I had a challenge with the Teams. It couldn't record my video. Therefore, I've used my presentation to not have the slides. I could have loved that it have the slides because it's easier to explain when there are slides. However, what I've done, I have attached the slides from my report. So I will urge the lecturer and ask the lecturer to refer on my slides on the report. The introduction. The introduction, we're going to cover 3 topics: the project background, project overview, and the scope of work. Project background. The student was tasked to do the following: to provide a professional service for the planning and designing of a 4-lane road, to provide pavement and geometric design, to provide an overall project management of the proposed pavement design, to generate the final alignment by utilizing commercial available geometric design software. Project overview. Objective of a project overview: to upgrade a gravel road that has reached its design lifespan to a medium-high 4-lane. The road is experiencing an increasing traffic volume that are traveling between Petrostene and Reeds location. The proposed road upgrade will be approximately 3.5 kilometers long, with a width of 30 meters road reserve, 2-meter median, 4-lane of 3.7 meters, and the Vigrins. I, Sipho Samkelo Ngoza, was appointed as a design engineer for this preliminary design report. The scope of work. The scope of work entails the following: examining the current state of the road alignment, a presentation video that will be uploaded to YouTube, a detailed design report, assessment of the traffic impact, geometric alignment design, pavement design. Design data. The design data will also include the following headings: project location, terrain, climate, traffic, and road reserve. Project location. Again, my project location includes pictures or picture of the location of the area. I do not have it with you in front of you, but I'm going to urge that you can look at the slides. The project is located between Petrostene and Reeds. I have the beginning of the construction and the end of the construction. I also provided the coordinates of the area. Terrain. The area is located on a gentle slope. The area exhibits an average slope of between 5% to 15%. Climate. The climate condition of the area is moderate, approximately to 2 to 5 N value. The annual rainfall is between 600 millimeters. Between 600 millimeters. Traffic. The traffic, we're going to touch again on the traffic as we continue on the report when we touch the calculations of the traffic. But for this purpose, the AADT for the proposed project is 756 vehicle per lane per day. Road reserve. I've attached a design of a road reserve that includes all the aspects of a road reserve. Design project and category. Design project of this report is 20 years according to TRH table 4. I have attached the TRH table 4. that shows the span of the road. Our span of the road is category B. The category of the road is B, and the span ranges from 15 to 30 years, and high certain it's 30 years and low certain it's 25 years. Then our lifespan of the road will be 20 years. Pavement design. Pavement design, we're going to discuss on the design information, projection of future traffic growth, and CPR calculation. Design information. Now, some of the information that I have in front of me, we have mentioned before, but what I've done, I've summarized it in the form of a table. But for this purpose of presentation, I'm just going to go through the table, and we can always refer to the report and also the slides that are attached from the report. Description. A light traffic rural road. Service level is moderate to high level service. Road length is 3.5 meters. Number of lanes, there are 4. It's divided years. E80. A80 class is SE10. Current traffic is 756. Structural design period is 20 years. Growth rate is 4%. Projection of traffic for pavement design. Now, again, some of the information for the projection of traffic we have touched based on it. But now I'm just going to go on the calculation part. And in front of me, I have the calculation of AADT after 20 years. I'm not going to go on the calculation step. I'm just going to give how many vehicles per lane per day after 20 years. Now, the AADT after 20 years will be 1,656 vehicles per lane per day. And the calculation slide, it follows the calculation for E80. Please again refer on the slides. The calculation for E80 is 8.5 million. Pavement class for this road is ES10. That is between the range of 3 to 10 million. CPR calculation. I've done 3 sections or 3 different CPR sections. So I have the calculation in front of me. What I'm going to do, I'm just going to mention the design CPR of these 3 sections. Section 1, the CPR calculation for section 1 is 3.8%. For section 2 is 5.7%. For section 3, it's 17.9%. Civil design software. We have used the civil design software to design the layer works, to design the horizontal alignment and the geometrical alignment. I have summarized the steps in the form of a table of what I've done to get into the drawings of producing the horizontal and the vertical alignment. I'm not going to go into details of the steps. What I will do, I will just go to the screenshots that I've done based on these steps. Now, screenshot number 1. Import survey points and triangulate. Again, I have a screenshot in front of me. We can refer to the presentation, and also we can refer to the report. Screenshot number 2, generate contour lines. Screenshot number 3, create template for dual cross section. I have 2 screenshots in front of me for dual cross section of the road. Design speed. The design speed is 100 of our road. I have calculation that shows screenshot that shows the design speed. Horizontal alignment. I have 2 screenshots. Design that shows the horizontal alignment. Vertical alignment, same thing also applies there. Curve calculation. In front of me, I've done the curve calculation in the form of spreadsheet and tables. And so what I'm going to do, I'm going to touch based on what I've done. I'm going to highlight the important aspect of the curve calculation. One of them being the grade. G1 is 2.24% and G2 is 1.4%. PI elevation is 78.9. PI stake value or chainage is 232. The calculation for the calculated length of the curve is 81.8. Calculating BVC chainage is 157 meters. Calculating EVC chainage is 307. Calculating elevation of BVC, it's 78. Calculating the elevation of EVC, it's 78.5. Calculating the value of K, it's 39.18. Site distance, it's 47.646. Subgrade. A subgrade design is to protect and improve the bearing capacity of the in situ material so that the pavement will fulfill the service objective. This is achieved by the use of appropriate material of the road. I have a subgrade design in front of me. I have 3 subgrade design 1 and 2 and 3. However, for the purpose of this presentation, I'm just going to touch base on the alternative that was chosen. On the alternative that was chosen, we have asphalt, base, sub-base, and selected layer, and road bed. On the asphalt, we have chosen a continuous grade, medium grade, 30 millimeter thick, and the base is 150 millimeters pressure stone of G5 material, and it is compacted to 88 of Mount Ashton. Base, sub-base, is 150 stabilized natural gravel seafoam, and it is compacted at 97 of Mount Ashton. Selected layer, SSG, it's 150 natural gravel material, G4 compacted at 95%. Roadbed, it's rip and recompact to 90% of Mount Ashton. Maintenance management. Maintenance management will be carried out according to TRH4, and hours spent for the road it's 20 years. Then the road will need surface improvement after 10 years. Then the road will also need a structural improvement after 15 to 20 years. On that note, ladies and gentlemen, I would love to thank you for your time to listen at my presentation. And also, I would love to say for getting more insight of what I just presented, I would urge the lecturer to look at the slides which are attached on the report. I thank you very much.